Hello all and welcome to Rust for C Engineers series. Let's get started. Today we are going to discuss about the most important workflow development tool called Cargo. Okay, to give a background and history, the name cargo comes from the shipping industry. Okay, so in the real world, a cargo ship actually transports cargo goods to the destination. So if you see, this is the cargo ship. It has got so many containers carrying cargo goods. Okay, so each container is called a crate. Okay, so assuming that this container crate has got electronics, this has laptops, say phones, televisions, clothing, textile, food products, say grains, chocolates, automobiles, say fruits, toys, medicines, medical equipment, say books, paper and paper products, and etc etc etc. Okay, a cargo company, apart from handling these, it has so many things to do, right? So one is, say, it has to accept all the shipment, it has to organize all the packages, it has to track them, it has to store them, then route them, deliver them, before that verify the destinations, and also handle all the documentation if there is any. Okay, so similarly, the cargo tool in Rust does so many things. It's the official build system. It's also the package manager and project manager. So we'll see it, okay, shortly. So cargo is basically a command line tool, and it creates the project, it organizes the source code, it manages dependencies, it compiles the project, it can run tests, it can also generate documentations. Okay, and also it can build release versions and debug versions. Okay, so and cargo is very powerful. So supposing your project has, say, 500 source files, right? If you just modify one file, cargo exactly knows what to rebuild, and this makes the process faster. Okay, let's see. Let's check the cargo version that we installed. Okay, so cargo is already installed. So we saw the installation process and cargo comes as part of that. Now let's get started. So to create a new project, let's say cargo new hello. Okay, so these two are common and you can give any name here. So here I have given hello. Okay, so it created a nice directory structure. Let us see. Okay, let's go inside the directory hello and say what is inside. It has got one directory called source and another file called Cargo.toml. Okay, let's visit this again shortly. Let's go inside the source. So inside the source already we have a .rs file. Main.rs is already created. It came ready-made. Okay, let's see what is inside it. So inside it already has hello world program. Okay, so we discussed that because cargo is a development workflow model, it has an agenda to make sure that the development environment is set up correctly. Okay, that's why it gives a ready-made program. Let's now compile this. So to compile, we use cargo build. Okay, so by default it builds the dev profile or it's a debug build. Okay, generally it's unoptimized and used in the early stages of development. But if you want the release version, we can say cargo build minus minus release. So here earlier it built the dev profile, now it built the release profile. Okay, so this, if you want, it has to be mentioned explicitly. Okay, now let us run it. So to run, we simply say cargo run. Because it's, the default is debug, the executable run also is debug only. Okay, the dev profile run happens, and if you see, it has created another directory called target and one more subdirectory called debug, and it has put the executable here, and then it executes, say hello world. Okay, similarly, if you have to run the release version, we simply say cargo run minus minus or hyphen hyphen release. Okay, so here it runs the release version. It creates a directory called release inside target, and this is the executable. Okay, and the output is hello world. So now inside source, so we saw that in the ship the containers are called crates, right? So similarly, a crate in Rust is a unit of compilation. So in simple terms, for this we can say this is the unit of compilation, so this is a crate. Otherwise, if there are many .rs files, all of them together which form one single binary is called a crate. Okay, this is a very common word generally used in Rust. Now let us see about .toml file. Okay, the .toml file ends with TOML, right? Cargo.toml. So TOML stands for Tom's Obvious Minimal Language. So this is not only unique to Rust, even Python has got .toml files. Basically, it was developed by or created by Tom Preston, so who is also the co-founder of GitHub. Okay, so he wanted to define and create, a simple configuration language, and this is what it is. Okay, so here in this case, it contains the package name and version, edition, etc. Okay, so version, this, if you have many bug fixes, you can manually change the version. So basically the dependencies, so if you have external dependencies of getting many libraries, you can define under this one. Okay, so now we don't have any dependencies because it's a simple main program, right? So in case of dependencies, we give dependencies here. But one thing we can change for sure. So if you are planning to use, say this cargo way, and supposing, it always creates main.rs and you want to give it a separate name. So what we can do, we can simply, for example, we can give another name called hello.rs. Okay, now we have two files, right? So this by default it executes anyways, but for this one we should add in the toml file. Let's add this. Okay, so this requires another section called bin. Now name, let us give as hello. Path, what is the path? Source / hello.rs. Okay, now how do we execute this? Say cargo build minus minus bin, say hello. Okay, now it built the hello version. Now how do we run it? Instead of build, we'll simply say run, and it ran the hello world program from hello.rs. So what if you want to have multiple files? Let's see that as well. Okay, so instead of hello.rs, let's copy and duplicate to hello1.rs. Same, let's open the cargo.toml file and copy the subsection again completely. Okay, and just let's rename it. Okay, hello1.rs. And let's first build it. So it is built in hello1. Okay, then let's run it. Run hello1. So what you do here now is that, like whenever if you want to follow the cargo way of building and you want to have all the files in one directory, you can do something similar to this one. Okay, another way we discussed is if you only want to learn about the Rust concepts, you can simply use Rust C and the program name, because if you want to write only standalone programs which have no dependencies, both are there. But this is a standard way, and Rustaceans love this way, and it's also a recommended way of build. Okay, so now if you see the structure, right, so we have another thing created as .lock. So okay, so earlier that lock was not there. So all we had is Cargo.toml and source, right? But now there are two more things created, right? So two more things created. One is Cargo.lock and target. So target we already saw. So once the compilation is done, the executable goes to target. So let's see what is the Cargo.lock file. So if you see Cargo.lock file, it's an automatic auto-generated file. Okay, generally it appears after the first build. So why is it necessary? So supposing in Cargo.toml file, we have defined all dependencies. Say libraries, say library 1, we are importing, right? We want to download the library, say, like 0.9 version. Okay, so but however on the server there might be so many like 0.9.1, 0.9.2, right? The exact version, downloaded version, is recorded in this file. Okay, basically it records the exact version of all the dependencies used by the Rust project. Okay, this is called Cargo.lock. We don't modify this file, this is only auto generated. Whatever file we want to modify is only in the Cargo.toml file. Okay, I think that's all for now. So but we still have this one text file created just to showcase. So here initially when you create the project, it contains only Cargo.toml and source file, but after the build it contains lock and target as well. Okay, so then apart from this, there are some cargo tools are there. Okay, let me just go over it very shortly. See cargo dot, let's go inside hello. Say first one is cargo fmt. Okay, it formats the entire project consistently. Okay, this is very much used. Then we have something called cargo clippy. So cargo clippy, what does it do? It finds common mistakes and suggests solutions. It suggests to make, suggest more idiomatic Rust code. Okay, so it analyzes a source code and suggests improvements. Cargo clippy suggests improvements to make it cleaner, more efficient and more idiomatic Rust way. Okay, it doesn't check whether the program compiles or not, it just checks how well the code is written. Okay, so this is basically to, it suggests improvements in code quality, to make readability better, to improve performance, and to make it, to make things simple, and it also suggests possible bugs and unnecessary code. Okay, then apart from this, Cargo also has other things like cargo test. See, now there are no test cases here. Actually, it has run zero test cases, but if you write test cases, we don't need a separate test framework for Rust. Okay, so if you have a test module, we can actually run test cases. It very much runs test cases. The next one, we also have something like cargo publish. So this is for publishing. So, publishing a crate to something called crates.io. For example, library, if you want to change, for now we don't need to deal with this. But if you want to change anything, publish a crate to crates.io to make it publicly available for any Rust developer to use. You can use cargo publish. Okay. So apart from this, we also have something like cargo documentation, cargo doc. It builds documentation. Okay, so if you go to this document directory, we can see all the documents. So for now we have only main program, right? The documentation is not helpful, but if you have lot of files, all the functions, parameters, variables, everything will be listed very beautifully. Okay, this is documentation. So this is about, today we covered so many things about cargo. Okay, I think that's all for now. Okay, and next week, next class, we'll learn about again Rust concepts, chapter 2.